Hello. In this video, I'm going to cover section 10.2, Angles from Contemporary Mathematics by OpenStax. The following are the learning objectives for this section. Identify and express angles using proper notation, classify angles by their measurement, solve application problems involving angles, compute angles formed by parallel lines, and solve application problems involving angles formed by parallel lines. We begin our study of angles with a description of how angles are formed and how they're classified. An angle is the joining of two rays, which sweep out at the sides of the angle. Each of these have a common endpoint. The common endpoint is called the vertex. We often need to refer to more than one vertex, which the plural is vertices. Angles are measured in radians or degrees. So for example, an angle that measures pi radians, or 3.14159 radians, is equal to the angle measure of 180 degrees. So kind of like that idea of metric versus US system of measurements, radians is more of a metric. In fact, radians is the metric measure of an angle. And then degree is more of a quote-unquote common person measure of an angle. And so to translate an angle measured in degrees to radians, we have this conversion factor of pi times 180, or sorry, pi divided by 180. So that takes us from from degrees to radians. And then to go from radians to degrees, we multiply by the flip of that, or what's called the reciprocal, which is 180 divided by pi. So that's how we can switch back and forth between radians and degrees when we're measuring angles. So we have four distinct ways of classifying angles, two of which are special angles. So here in the first type of angle, a straight angle is one that makes up a straight line, and they measure 180 degrees. And then the next angles is this, also known as a right angle, is 90 degrees, and that's in measurements and a tool that we use to measure, that is called an L bracket. L brackets are what's used to make a 90 degree angle. And then we have acute angles. So acute angles are less than 90 degrees. Sorry, there's a typo here. This should be who. Let's measure. But acute angles are less than 90 degrees. So for example, a 60 degree angle is an acute angle. It's less than 90 degrees. And then an obtuse angle is an angle whose measure is greater than 90 degrees. So this is less than 90 degrees, and 135 degrees is greater than 90 degrees, so it is obtuse. All right, so naming angles can be done in several ways. So the way we name angles typically is by 3 points, with the middle letter being the vertex. And we can also use these symbols, these little angle symbols. Typically, this first symbol just is angle, and this second is for the measurement of an angle, but they can both be used interchangeably for an angle. And then when referring to the measure of an angle, we typically put an M in front for the measure of an angle. And again, we like to use these notations in mathematics so that we can say a whole lot of words in any language, but with symbols. So two angles with the same starting point or vertex and a common side are called adjacent angles. So let me give you sort of a picture example of that. So let's say that we have this type of picture. We'll say this is A, B, C, and then D. Then these two angles here, so angle ABD and angle CBD, these are adjacent angles. They share a common ray, so they share a common ray BD. So that is what makes them adjacent. So if two adjacent angles sums up to 180 degrees, we call those supplementary. So supplementary angles add up to 180 degrees. So let's look at an example of how to solve for angle measures with supplementary. This does require a little bit of algebra, but very easy algebra. So it's not going to be too involved. So here we have two angles. This is a straight angle, right? This is a straight angle because it's in a straight line. And so straight angles together, both of these would add up to 180 degrees. So the sum of these two angles is going to give us 180 degrees. So that means that 32x minus 7 plus 5x plus 2 has to add up to be 180 degrees. Okay, so when we have this expression, first thing we want to do is combine like terms. Well, in this case, 32x and 5x are like terms, so that's going to give me 37x. And then negative 7 and positive 2 are like terms because they're constant terms, they're just numbers. And so that's going to give me minus 5 equals 180. And so to solve this, we want to work in reverse. We're trying to find x. And so to find x, we want to clean up around x, starting with the furthest away from x. So this plus 5 is the furthest from x. So the opposite of of subtraction is addition. So we want to add 5 over. So that's going to be 37x equals 185. And then here we have 37 times x, and the opposite of multiplication is division. So if we do 185 divided by 37, to get rid of the 37 with x, then what we end up with is 185 divided by 37, which is 5. And so x is 5. Now that's not the answer, that just tells us the missing variable. So in order to find the actual angle, we need to substitute, we need to plug that value in. So this angle here, so the angle measure is going to be equal to 5 times 5 plus 2. So that's going to be 25 plus 2. So that's going to be 27 degrees there. And then this angle measure is going to be 32 times 5 minus 7. And so if we do 32 times 5, that's going to give us 160 minus 7 is going to be 153. And then just to check our work, because those should be our answers, 153 and 27, and this should be in degrees. So to check our work, let's add 153 plus 27. So if I just check 153 degrees plus 27 degrees, that gives me 180 degrees, which is what it should add up to because they're supplementary angles. Another special type of sum of angles is complementary angles. And so if two angles add up to 90 degrees, we call these complementary angles. So real quick, how do I remember the difference between complementary and supplementary? Well, remember that in the dictionary and in the alphabet, C comes before S and 90 comes before 180. And so that's an easy way to remember complementary versus supplementary is complementary is 90, supplementary is 180. C comes before S, 90 comes before 180. So let's do that kind of algebra manipulation again. Here we want to find the angle measures. So we have three angles here, and we have an unknown value of x. So we got to use our algebra skills again, but as you saw in the last slide, it's not that bad. So these three angles have to add up to 90 degrees. So that means that 9x minus 5 plus 4x plus 7x minus 5 have to add up to 90 degrees. So again, we want to add our like terms. In this case, the like terms are the x's and then the constants. So if we add up 9x plus 4x plus 7, we would have 20x. And then our constant terms, which make up our other like terms, would be -5 and -5, and that gives us -10. So once again, we're down to, this is called a two-step equation because we're just going to do 2 steps to solve it. The first step is going to be add 10 because that's the furthest away from x, and the opposite of subtraction is addition. So we'll add 10 to both sides, and that's going to give me, and I'm going to have to move over here. I've run out of screen space, so 20x equals 100, and then divide by 20, so x equals 5. So x is 5, so that means we're going to go back and plug into here. So we'll have 7 times 5 minus 5. So that's going to be basically the same thing as 6 times 5, which is 30 degrees. Here we're going to have 4 times 5, which is 20 degrees. And here we're going to have 9 times 5 minus 5, which is basically the same thing as 8 times 5, which is 40 degrees. And of course, it's good habit, since we have this and we know that they should add up to 90, to do 40 plus 20 plus 30. And so 40 plus 20 is 90 degrees. So that tells us that we did our algebra correctly and we found the correct angle measurements. So that's complementary angles. They add up to 90 degrees. So when two lines intersect, the opposite angles are called vertical angles. So to look at that, so here are two lines. We'll call this L1 and L2. These angles here are called vertical angles. And they are opposite of each other and they are equal. And then here, these other two angles are also vertical angles, and they are also equal to each other. And that's just a property of when they intersect, when lines intersect and create these angles, that we have these equal angle measurements. So let's see how we can use that. So here we have a given angle that we've measured to be 40 degrees. How do we find the remaining angles? So we're looking for the measure of angle 1, the measure of angle 2, and the measure of angle 3. So right off the bat, because these are two lines intersecting and they've created these vertical angles, the measure of angle 2 is known to be 40 degrees. We get that automatically kind of as a freebie thanks to vertical angles. The next angle we can find is either 1 or 3 because they make a straight line together, and that means they're supplementary. So that means angle 1, the measure of angle 1 plus 40 degrees has to add up to 180 degrees. So that means that if we subtract 40, that the measure of angle 1 has to be 140 degrees. And that's awesome because now that we have measure of angle 1, we get a vertical angle of angle 3 for free. So we know that it also has to be 140 degrees. All right. So what happens when you have two lines that are parallel from each other and they're intersected by a third line? Well, what happens is 8 different angles are formed, but a lot of them are actually equal to each other. So they are distinct angles, but their measurements, a lot of them are the same. And so we have various types. We have alternate interior angles. We have alternate exterior angles, corresponding angles, vertical angles, and supplementary angles. So we've already talked about vertical and supplementary angles. We need to talk about what does it mean to be alternate interior and alternate exterior, and corresponding. So when we have the idea of interior versus exterior, what we're talking about is in terms of the parallel lines. So interior to these parallel lines, let me highlight the parallel lines. So interior to these parallel lines are 3, 4, 5, and 6. So 3, 4, 5, and 6 are interior to the parallel lines. And then when we talk about alternate, we're talking about with respect to the transversal. And so alternate means kind of opposite. So 1 and 2 are alternate, but one is, well, and they're both exterior. So we're talking about, for example, let's look at alternate interior angles. So 3, 4, 5, and 6 are the interior angles. 3 and 6 are the alternate interior angles. And if you look the way this is drawn, it makes this Z, and 3 and 6 are actually equal to each other. So these are alternate interior angles, and they're equivalent. So 3 and 6 have the same measure. 4 and 5 have the same measure, right? Because they are also alternate interior angles. 2 and 7 have the same measure. They are alternate exterior because they're on the opposite sides of the transversal and outside of the parallel lines. And 1 and 8 are also alternate exterior angles. They're on the opposite sides of the transversal, but outside of the parallels. All right, so this just kind of sums up the alternate interior angles, highlighted there for 3 and 6. And then 4 and 5 are also alternate interior angles. That's what I just described, but this gives you a picture of those specific alternate interior angles. Just to highlight 5 and 4, or 4 and 5, are also alternate to each other and interior. And then alternate exterior would be like 2 and 7, but 1 and 8 are also alternate exterior to one another. They have the same angle measure as well. Now, what I didn't mention was corresponding angles. Corresponding angles are ones that are in the same position on the parallel and the transversal. And so, for example, 1 and 5 are corresponding, 2 and 6 are corresponding, 3 and 7 and 4 and 8. Those are all corresponding angles, and they also have equal measure to each other as well. So let's look at an example of how we can use kind of some of this together. This doesn't use the parallels. This uses something a little different. But suppose you live on the corner of First Avenue and Linton Street, and you want to plant a garden in the far corner of your property and fence off the area. However, the corner of your property does not form the traditional right angle. You learned from the city that the street causes the angle equal to 150 degrees. So what is the measure of the angle that will border your garden? So here is 150 degrees, right? So we're trying to figure out what's the angle right here between First Avenue and Linton Street. Okay, well, if we were to get rid of all the nice kind of, picture here, then really what we have is this intersecting lines, right? This is that L1, L2 line intersecting picture with 150 here, and we're trying to find this angle right here. Well, they make a straight line with each other, so that means that if we're looking at this, we'll call this angle 1, then the measure of angle 1 plus 150 must add up to 180. So what's the difference between 180 and 150? Well, that's 30 degrees, right? So that means that it makes a 30-degree angle. So the measure of the angle 1 is going to be 30 degrees. Now here's one that uses the transversal. So we want to find the measure of the remaining angles and kind of give a reason for our solution. So I'm going to go ahead and write in the measure of angle 1 is equal to, and I'm going to put over here, this is going to be my reason, and then the measure of angle 2. And I'm going to pause the video while I fill this in. All right. So over here on the left, we're going to figure out the value, and on the right, we're going to give the reason. So the reason's going to be, are they alternate interior? Are they alternate exterior? Are they supplementary angles? Are they corresponding angles? So that's going to be our reasoning. So what I like to do is kind of start with the give-me's, the ones that are going to be equal. So starting here, measure of angle 3 is known to be 40. So angle 2 is special with angle 3. They are vertical angles, and vertical angles are equal. So the measure of angle 2 is also going to be 40 degrees because they're vertical angles. And then the next kind of freebie we get is angle 6, because that's also going to be equal to angle 2. So 6 is also going to be 40 degrees. And that's because they're corresponding. Notice they're kind of in the same place on the parallel lines, so they're corresponding. Well, that also gives us, well, you could also say 40 is corresponding to angle 2, or you could have said that it's alternate interior to angle 3. So either one of those are actually justifiable reasons for why angle 6 is also 40. So I'm just going to go with corresponding, but you could also say that it's alternate interior to angle 6. So 2 ways there. 7 also has 2 ways to say that 7 is 40 degrees. So 7 is 40 degrees. One of the reasons that it's alternate exterior to 2, so 7 and 2 are alternate exterior to one another because it's on the opposite side of the transversal and outside of the parallel lines. But they're also, 7 is vertical to 6, which we just said is equal to 40 degrees. So either of those two work. For 7, I'm just going to go alternate exterior to angle 2. Everything's going back to angle 2, or I'm trying to, as much as possible, relate it back to angle 2. And then the next one we have is, so that takes care of all of the ones that would measure 40 degrees. So then the question is, how much is, for example, angle 1? Let me get a different color here. All right, so angle 1 is going to have a different measurement. Angle 1 and angle 2 make a straight line. Angle 1 and angle 2 make a straight line. So they have to add up to 180 degrees. So what's the difference between 180 and 40? So that's going to be 140 degrees. So that means that angle 1 has to measure 140 degrees. And that's because they're supplementary with angle 2. And then from there, we get that angle 4 is 140 degrees because it's vertical to angle 4. So vertical to angle 4. Angle 5 is also going to be 140 degrees because it is alternate interior to angle 4. And then 8 is also going to be 140 degrees because, 2 reasons, actually several reasons, but 2 quick reasons is, number 4 is corresponding, or sorry, 4 and 8 are corresponding. And that gives us all of the angles all in one kind of go. And again, each one of those could have separate reasons. The point is that, are you using the correct reason? There could be multiple for each one. All right, let's look at a similar example. We want to find the measure of the angles that are missing in this other picture. And we know that lines 1 and 2 are parallel. So in math, we can use this little angly bracket. Let me put one on here. So this little angle bracket to indicate that lines 2 and lines 1 are parallel to one another. And that's going to be kind of helpful in finding angle measurements with like corresponding and alternate interior and such. All right, so let's go ahead, let's get started talking about some of these angles. So we're given here that the angle of here is 62, all right? So we can kind of find all of the angles touching it. Actually, let me kind of go in a better order. So again, let me write down all of these measurements and the numbers. All right, so now that we're looking for 2, 4, 11, 12, and 14. So let's start with the fact that, we're going to start with the fact that 62 degrees is given up here. So this is 62 degrees. So because L1 and L2 are parallel, and we have this transversal here, then 62 degrees and 4 degrees are corresponding to each other. So the measure of angle 4 is also going to be 62 degrees because of corresponding angles. So corresponding to angle, 62 degrees. And so that gives us a 62 degrees. Now we can find, we don't need 5, we need 1. And so 1 is actually equal to 4 because they're vertical angles. So angle 1 is also 62 degrees thanks to vertical angles. It's vertical to angle 4. So how do we find angle 2 here? Well, notice that all of these angles here make up a straight line, okay? So that means angle 2 plus 62 plus 62 have to add up and give us 180. So if we do 180 minus 62 minus 62, then that's going to tell us angle 2, which is 56 degrees. So angle 2 is 56 degrees, and that's because these 3 angles are supplementary. They all must add up to 180 because they're on a straight line. Now, what about, let me switch colors. What about up here at angle 11? Well, angle 11 is vertical to the 62 degree angle, so 11 is going to also be 62 degrees because of vertical angles. And then what about 12? Well, we can find 12 because 62 and 12, 62 degrees and 12 right here, they're on a straight line, so they are supplementary angles. So if we do 180 minus 62, that gives us 118 degrees. So that's because they're supplementary. And then finally, we want to know 14. Well, we get 14 for free because if 12 was 118 degrees, angle 14 is vertical, so that means it is also 118 degrees. So that is because of vertical angles. And we could continue because, once we've got all that information, we can find the rest. But most of the rest just come from alternate interior angles or corresponding angles or vertical angles. But this is all the question asked. That's all we're going to do. But, if you want to challenge yourself, you can find the rest. So that's it for this video. If you haven't already, I advise you to go read section 10.2. There's more examples and further explanations in there. While you're reading the section, I highly advise you take handwritten notes and attempt all of the your turn problems for the section. And then once you've done that, head over to the learning management system and work on your online homework.